Hi everyone. Today I would like to show you some of the design patterns that I use really in every single Go application that I develop, and I can't really live without them, to be honest. So before we dive in, please consider subscribing to the channel. This would really mean a lot to me. Now let's dive right in. So the first thing that I would like to mention is this NTIA architecture. It's not really considered a design pattern, but I still think it's worth mentioning here because it's a way to develop the architecture of your app. And the idea behind NTIA architecture is that your app should consist of layers. For example, it can have an infrastructure layer, configuration layer, persistence layer, services layer, and presentation layer. These are at least the layers that I constantly use in my apps. There can be more layers depending on the complexity of your app. So those were the layers that I always use in my apps. And I can show you what it actually looks like. So if I go to my Backend Go app, this is what the folder structure looks like. And if I open, for example, the Docker file, this is basically the whole infrastructure layer. So with this Docker file, I'm basically saying this is how you deploy this app using just Docker run. So, which means you can deploy this app to Kubernetes, you can deploy this app to Google Cloud Run, and similar solutions. Now, this infrastructure layer has actually a few other components. For example, this env.example, which kind of tells you that environment variables is the way to configure this application. And then you also have Docker Compose. Now I don't use Docker Compose actually in production because here, as you can see, I have my database, so I don't really use Docker Compose, so I don't really use this file in production. It's just for local development, but this kind of tells you that this application needs a database, for example, Postgres database. And this is not really necessary, it's just an interface to look into the database. But this Docker Compose file just tells you what this application actually needs. So I might also have Redis here if I needed Redis. So this was the infrastructure layer of the app. Now the next layer of the app is actually the configuration layer. As I mentioned before, you can and should use environment variables to configure this application. And then this configuration is actually parsed by configuration layer. And this is what it looks like. It's actually just two files. In this config.go file, we define the configuration schema with all the names of the environment variables with their default values. For example, I have here like basic auth to protect the API documentation. I have here SMTP settings, LLM implementation, and API keys, and name of the bucket, JSON Web Token configuration, and stuff like that. And the other file is just to load this configuration into RAM. So this was the configuration layer. The next layer of the app is the persistence layer. And for persistence, I'm using Ent. Ent is a Go framework to provide a unified interface to communicate with the database. It actually looks like this. So you have this model package, and inside of this package you have the schema folder, and inside of the schema folder you define what your database models or database tables should look like. For example, here I have a model for dish, and it has an ID, it has a name, weight, calories, protein, and so on. And then I have stuff like events, and then I have a user, and there are edges between these models which build relationships between models. So for example, as you can see here, I have a user ID, and this user ID or this events table is connected to the users table via this user ID field. And when we delete a user, it also deletes the corresponding entry from the events table. So all of that you can basically define in the schema, and then you just generate the actual interface to communicate with the database. So this is the persistence layer of my app. And the next layer that I have is the services layer. Here I have, for example, this dishes package, and I have this maker service, which I use to convert the user input into a dish. And here's what it looks like. So I use an LLM to do that. I have some prompts here. So long story short, this services layer implements the business logic of the app. So here I have, for example, a dish maker. So it's dishes maker, and it has a few functions, such as, for example, I think the most important function here is create, and this create function actually implements all the business logic of this app. So it's actually, what I'm showing now is actually a facade pattern as well, you could say, because behind this simple interface, which is just this create function, there's a lot of business logic going on, and it can be configured in many different ways using these options that I provide as arguments. So it's basically the core of my service layer. And now the last layer of the app is actually the presentation layer, and it looks something like this. So here I have all the endpoints of the app, all the endpoints of the API defined in this file using these controllers. So I have actually many different controllers here: capabilities controller, self controller, promotion controller, users controller, and so on and so forth. And each controller defines multiple endpoints, and these endpoints are bound to the actual URLs here. So this was the Entia architecture, which is an architectural pattern. It's not really a design pattern again, but it's very, very useful, and I think it was worth mentioning because it allows you to build layered architectures. And to be honest, in my opinion, it is a design pattern. And then we have here more classical design patterns. It's not all of them. I mostly use only these four, and these are also the four that I can show you in the app directly. So let's see what the dependency injection design pattern looks like. As I mentioned, I have controllers here, and one of the controllers is this dishes controller, and I think it's a good example. Yeah, exactly. So this dishes controller actually has multiple dependencies. For example, this dish maker, which I showed you, it has the database itself as a dependency, it has the bucket as a dependency, it has event counter and allowed scans per day. This controller itself, it doesn't really know what values or what implementations are injected here. This is basically a repository to access data, but it doesn't know what kind of database it deals with. It doesn't know, am I dealing with a MySQL database? Am I dealing with Postgres database? Am I dealing with MongoDB? Because the only thing that this dishes controller actually cares about is all these interfaces. So it's just a contract between this controller and the other components of the app. All these components are injected into this controller using the concept of dependency injection. And to implement dependency injection in this app, I am using Wire. Wire is a framework by Google, and here you just define providers. So here you actually define your kind of initial object that everything is based on, which in my case is the configuration of the app, and then I can provide all the dependencies that my app needs. For example, I can provide this SQLX interface, and then using this SQLX interface, I can provide the database itself here, so it creates this model client, and then I can provide this model client to other components that need this model client, for example, this capabilities controller, users controller, and so on and so forth. So basically, the important thing here to remember is that you define this kind of initial thing that everything depends on, and I think I define it inside of this main function. So here I load the configuration, and here I use this initialize app function, to which I'm passing this configuration, and then everything starts with this configuration, and it creates all the things for which I created providers. And you can build really complex dependency trees using this Wire framework, as you can see. Some of my controllers have really lots of dependencies. For example, this dishes controller, meals controller, and other controllers as well. So this was the dependency injection design pattern. Then I have the decorator design pattern. The decorator design pattern is used to modify the behavior of an object without modifying its interface. So for example, here I have it actually at 2 places. So if I scroll down a bit here, I define these controllers, or I bind these controllers to endpoints, and the actual function of this controller is actually get self or delete account. But as you can see, I'm not directly passing this function to this delete function or to this get function. Instead, I'm wrapping it with this other function with our context, which is actually a decorator that just gives a bit more context to my endpoints. So here I'm using this. Here I have this get self function, and as you can see, it has a context, and it's actually not in the native context. Instead, I created my own context, which has some additional values here, such as user, IP address, and this is actually what this decorator pattern looks like. So I basically embed this native context, and I also add some other helper functions, which I can then use in my controller functions. For example, here I can get the user from my context, and all the implementation details are kind of hidden behind this other decorator, which is a decorator for the actual API handler. Now the next design pattern is the repository design pattern, and the repository design pattern inside of this project looks like this. So as I mentioned, I'm using Ent for the persistence layer, and you can actually call it a repository, because the idea behind the repository design pattern is that you can have a unified interface to access data inside your app, and it doesn't give you any details about what implementation is injected here. So I can show you what it looks like from the kind of consumer perspective. So this endpoint or this handler is actually a consumer of this repository, and as you can see, the usage of this repository looks like this. So I have this kind of I'm saying here basically find an event where it has this user ID and it's between today and tomorrow, and count the events that you found. So this is basically the usage of this repository design pattern, and at this point I don't know what database is actually being used. So this is the whole idea of the repository design pattern, and I can also show you what it looks like at other places. For example, I don't know, here, client meal entry, find all the meal entries between the current date and the next date, and that are assigned to this user, and get me also their relationships, and so on. So this is another use case for the repository design pattern. I'm actually using it all over the place to access the data. And then the last design pattern that I'm going to show you is this bridge design pattern. And the bridge design pattern is especially useful when you connect to some external services, such as, in my case, an LLM and a bucket. And this bridge is actually this interface in this case. As I mentioned, I needed a functionality of a bucket, so I wrote this interface which describes what it should be capable of. So I should be capable of putting something into this bucket. I should be able to check if a file exists in this bucket. I should be able to download it, and so on. And then I create an implementation for this interface, let's say for GCP, because I'm using Google Cloud. And here, as you can see, this implementation has all the details how you should communicate with this bucket, but my app actually doesn't really know what implementation is injected here. So today I'm using GCP, tomorrow I might implement S3, and I can use S3 instead of GCP. And the same thing applies to LLM. So here I have also just an interface which my app is using, and my app also, in this case, doesn't know what LLM is injected here. It just knows, okay, there is an LLM with this interface, and this is all it knows. And then all the implementation is inside of this rather bigger file, and the app doesn't really care about this implementation. So this was all for today. Thanks for watching.